Today I'll have a small toy problem. We are going to handle how we can handle machine learning problem in Python. The main problem that I'm going to handle is a classification problem. I hope you remember we had a session on machine learning where we discuss what machine learning is. And as I told you before, in machine learning, our input will be a data set, or in other words, the input is a data and the outcome will be depending on our requirement. It could be, if it is a classification problem, we are trying to predict a label. If it is a numerical prediction problem, then we are trying to predict a value. If it is an association learning problem, we are trying to predict the association between a variables, right? So when we talk about the algorithms, we discuss algorithms can be used to detect the structure of the data. So the examples that we have seen is given a data set. We will, using machine learning algorithm, we can build a model. So today we are build a decision tree algorithm based on the data set, and that is the problem we are going to handle. And I'm going to explain the whole machine learning using this one. Right. Okay. So let me switch to the other note. So here's the example that I'm going to use for today's session. This is a toy data problem where we call IRIS dataset. It's commonly used dataset to teach classification problems. The problem is as follows. There are like 3 types of flowers, and visually they look the same, right? You can see there are 3 types of flowers: versicolor, setosa, and virginica. They visually looks the same. So what we are trying to do here, we are going to first collect some data set, measuring some characteristics of these flowers. And based on the data that we are trying to build a model, which could be used to predict when you're given a new flower, we are going to predict the type. So that is a classification problem, right? So the data set look like this. There are 150 samples, the data points. The 3 labels, we have the 3 classes. And then there are 4 measurements: sepal length, sepal width, petal length, petal width, and so on. So they are measured in centimeters. So the measurements look like this, and data samples look like this. So in the data set, we have 150 data points. And then we have 5 features, including the class label. So the 4 features, they are numerical data points, right? Because they are measured in centimeters. And the class label, we have a label we have given for the type of flower, right? So any question on this one? Are we clear on this, Nigara? Yes? Right, data set okay, right? So this is the first thing we need to understand. The dimensions, we have 150 data points. We have 4 features and 1 class label, right? Okay. So let's look at how to load the data set. First of all, let's load the important libraries. The first one, numerical Python, we already discussed it. Then visualization, we discussed last time, Matplotlib. Other than that, we are going to get the data set from the scikit-learn library. Please load these 3 examples and get ready. So I'm going to open another new window, right? Colab. We are going to open our notebook. Where's our, okay, today is session number 6, I guess. So I'm going to rename this. This is session number 6. And then I'm going to go down. Okay, this is the last one we did. Okay, I'm going to ML with Iris data, right? And that is exactly what we are going to do today, right? I told you like the 3 important packages. The first one, NumPy, we can say import. We can say import NumPy as NP. This is for matrix handling. And then import matplotlib.pyplot as PLT. This is for visualization. Import sklearn, right? Okay, so this one, actually, we are going to get only the data set. So I will put in the other way around. We'll say from sklearn, we are going to import data set. So 3 things we imported. The first one, NumPy arrays, matplotlib for the visualization, and the data set from scikit-learn. Right. Until others are get ready, you can visit the web page. So if you go to sklearn, right, here is the website. This is mainly used for machine learning and quite popular machine learning library in Python, right? So most of us nowadays, we rely on this, and there are other packages as well, which is quite useful. And as I told you, today we are handling a classification problem. Many algorithms are already implemented under this. You can see some of them. Regression for numerical analysis problem, you can also have many algorithms are implemented. Clustering, that means grouping. Again, we are going to discuss later on. Identifying similar groupings in the data. And also, if time permits and if you are willing to learn, we can even go for dimension reduction as well, right? So everything we can use this particular Python library. Right. The next point that we are going to discuss. Now let's load the data set. Now to get the data set, we have a data sets, and we are particularly going to learn this Iris data set, and let's see how it works. So I'm going to type right. So this part we done. We have loaded all the required modules. Now we are going to create the data set. So we have to get data set like this, data sets underscore load Iris. We have to say datasets dot load Iris. It should be dot, right? Should be dot load underscore Iris. And then I'm going to get this to a variable. I'm going to say Iris. So what happens? We get the data set and we load it to this. Just print and observe what is inside. We can say print Iris. right? Observe the outcome. Because we have already done the basics. Please let me know. That's why you are here. Any questions? So what we did so far, we load the modules that we need for today's session and we open up a dataset called IRIS dataset. So now let me explain. Right now, let me explain the data set. If you look at the data set carefully, now you can see it starts like this. In the beginning, we have a curly bracket. We have a label called data. And then there will be a NumPy array. You see here array word array. So it's a numerical Python array. So that's the data set. And this is represented as a dictionary. I don't know whether you remember the dictionary data structure. So you have a key and value pair. So this is the key, that is data, and array is the value, right? So that's the data part. If you go down, because we have 150 data points, if you go down, there are others as well. We have another label called target. That is our class labels. Again, 3 labels are there, 0, 1, and 2, which will represent the 3 classes. If you go along this one, you can say frame none. Target names, again, there's an array. The names of the 3 flowers, data type, and some more information. So you can see there are a lot of information is here. But remember, the most important part is the data, right? So let's take data out from this dictionary. Now, to get the data out from the dictionary, simply if you remember dictionary, how to handle this, we can simply use a dot operator, or we can call it, right? So let's create two variables to get the data into one point and also the target, the class is another. Right. So to start with, I'm going to get the code. I'm going to say X. This is my data set. So we have iris.data. And if you take now X, you will see only the data part we will have. Just go through this. You can see now data, we are going to keep it as X. Have you all finished up to this point? So when we say iris.data, we will get only the data part of it. Similarly, so now the next one, let's take the target. That means the class label. We'll take it to another variable. Let me take another code window. I'm going to say y iris.target. And just print y and c. Yes, this is what we are getting. So these are the labels. Now let me summarize what we have done so far. We have taken a data set from the scikit-learn library, which we call iris. And then we have taken data as X, target, that is class label as Y. That's all we did so far. Now look at the dimension. Just check the dimension. You remember the command to get the shape? We called shape, right? Just check the shape. I said x.shape. It says 150 rows and 4 columns. Right? Similarly, if you take y.shape, we have 150 data points. I hope you are clear up to this point. Right, okay. Next one. Now let's take some data out and see. Now, for example, what I want to see the first parts, just to observe how the data is look like. Maybe I would like to see first couple of data points. Let's try to see the first 10 rows of data, right? Now this is a NumPy array and we discuss indexing. So for example, if you say X and you can specify what you want to have. Like if you put 0, do you remember what happened? When you say just 0, what will happen? It's the first row, right? If you say, okay, 0, comma, like let's say 5, it goes up to 0 to 4. 0, 1, 2, 3, 4. So first 5 rows. So if I need first 10 rows, then I can just put 10. And then even I told you that you don't need to put this 0 in the beginning. Simply you can put in this 4. So simply using this form, you can say, okay, you can just look at the first 10 records, right? First 10 rows of data. This is just, we are just going through the data set and see how the data look like. Right, similar way, shall we look at the labels as well? First 10 rows, let's look at the labels. So I can say y colon and 10. And if I run it, yeah, just zeros, right? Means our first class. Now let's try some columns. Okay. By the way, if you need like the last 10 rows, you have to say minus, right? Remember we discussed forward indexing and backward indexing earlier. So for example, if you need the last 10 rows, last 10 rows, so you can see, right? In this manner, you can get last 10 rows. Right now we are comfortable with the rows. Let's look at extracting some data columns. So let's take the first column, right? Just take the first column of data. The first. So X colon will represent all the data points. First one will be 0, right? So we can put it in this form. It should give you first row of our data set. Sorry, first column of our data set. So if you need the second column, you can just put it like this. Right, I have a small question for you. I want to get the first column and the third column. Right, in the data set, I want to get the first column and the third column. How do you get that? Now we have first column, if you just put 0. So let's say I want to get the first column and the third column. So the first column index is 0, third column index is 2, right? Okay. So we need both. Right. Let's get first column and third column. Right. X, this is rows. So we need 0 and 2, right? So if you do in that way, hopefully now we are getting 150 by 2. So 150 rows and 2 columns. So we'll get the data set like this. Okay. I need to visualize the data set. So that's the reason why I asked you to get first row and third column. Using these two columns, photograph pattern. Now we have first row and third column, first column and third column. Row and scatter from between these two. Can you do that? We have to use plot command, isn't it? We have to use plot command. And we have to use, yes. Take the third column as the x-axis. First column as the y-axis. So let's try to do this. Let's visualize. So the command is plot command. We know plt.plot. Okay, type what x and y. From previously we discussed how to get the first column, the third column, put them as x and y. If I go on the board, we have X data set is look like this. We have 150 data points. We have 150 data points and we have 4 columns. Yes. My question is take the first column. That means the index is 0. And then the third column index is 2. So I ask you to take this as a x, this as y. Right? So if I go from the beginning x, if I want to get the third column, I have to say, okay, all the rows. Third column, 0, 1, 2, right? So it should be 2. So this is my x values, comma. Then first column, 0. Just try running this. And okay, we are getting something like this. Can you tell me why? And this is exactly what we have asked for, and it gives us. It's a line plot, right? Because when you not specify anything, you get it as a line plot. So specify a marker. So for example, remember formatting string? If you put a marker, it puts O. Now you can see the data points. If you want to specify color as well, maybe red color, we can put R. I think we have discussed these ideas earlier. Yes. Now you can see the data points. Now, instead of plot command, you can use scatter command in case if you want to directly get the scatter plot. Okay. So what is your interpretation about the data set? What can you tell about the data set? Can we say anything about the data set by looking at this? What do you see? Yes. How many groups of data we can clearly see? We can see two groups here. Right now, we don't know the labels because we have not specified the labels. Now, let's try to specify the labels. That's exactly what I'm going to discuss next. Now, to specify the labels, right? To specify the labels, we have to separate out the data. We have to separate out the data. Right? Now, what do you mean by this? Now, in the data set, we have some information about the classes as well. In the data set, we have the information about the classes as well. If we can separate out these separately, we could do that, isn't it? We could do that, right? So let me try to do this, separate out the data, right? Now, here is what we are going to do. I'm going to copy paste this code. But now this one, not everything, right? I'm going to separate out with the class labels. Do you remember we discussed something called fancy indexing last time? I don't know whether you remember. With fancy indexing, you can search for particular value. So similar thing we are going to discuss here as well. Right? Let me explain. Now here is what I have. This is what I have. We have X. We have, we are selecting all the rows here, right? Now this specify all the rows. Now what we want to do now? Do we need all the rows? No, we don't. What do we need? Now what are the labels we have? Can you go through the Y and see what are the labels we have? In Y we have 0, 1 and 2. Now we can get only the Y values when Y is 0. So this is how we are going to say that. See whether you can understand, right? So what I'm going to say here, instead of this, I'm going to say, okay, I need all the values where Y is 0. You got my point? Instead of saying everything, we say, okay, I need when Y is 0. This is how we say. And I'm going to use red color here. Just plot it. And this time you will see Okay, I made a mistake here. So the mistake is, okay, I have to check not equal 0, isn't it? So the mistake I made, I just put 0 equal 0. It should be double equal, right? So it should be, okay. And what else? Okay, we have done this. Okay, y should be 0. Okay, now it should work. Exactly. You can see now. The trick that I have used is, instead of getting all the rows from the data set, I selected when y is 0. So the number of data points you can see very. So do this for the other class as well. Let me take another class. So I'm going to copy paste this one. So this time I'm going to take the y as 1. That is our second class. Let me put green. Now I hope you can see two groups of data. Can you complete the third one? The only part in the thinking behind this one I did is very simply I have selected the separate. Were you able to put the third one? Okay, so let's put the third one. So I'm going to put the third one. The third class label is, in my case, it's 2. So I will put 2 and 2 here. So let me put this as P for blue. Now you can see the 3 class. Right. Now I think we are doing machine learning, right? But just by observing this one, what can you tell about this visualization? What predictions, so what observation you can make by just going through this? We have three different classes, and one is, what do you think? More easier, like simple, easier. So the other two classes are kind of overlapping. So these are the kind of observation you can make in the beginning, and it's very important. We can see now out of the three classes, one flower can be easily identified from others, right? Okay. Now let's try to label this. Otherwise, we don't know what this red color means. What we don't know what green and blue means. Let's put up the labels. So let's put a title. So let's put up a title. Let's say plt.title. Let's say this is iris data. We have X label. Let me give you the label. X label should be petal length. That is what we had from the data set. So type this as a petal length. And type Y label. So this is sepal length. Finally, we label the data points. The three classes are, the first class is Setosa, Versicolor, and Virginica. And finally, we will say plt.show and run, observe the outcome. Now you can clearly visible what classes are clearly separable. Simply what we did, we improved our graph so that we have proper labels. We have labeled our classes. Now I want you to make some careful observation from the data points, from the values. Can you tell me, can you come up with a rule set for separate out, let's say Setosa. So this is my, right? This is my graph, properly labeled. Now you know red is stand for Setosa, Versicolor and Virginica is the other two. Setosa is easily separable. I have one question, like, can you come up with a rule to separate this compared to other two data sets? I need exact. I need exact. I have to provide that. Exactly, there's a label, right? But petal is right. Remember, petal. So in my case, let me check. It's a petal length in my case, right? It should be less than, let's say, 2.5. Can we say like that? Exactly. Now you have without machine learning, we have a rule, right? We can say, okay, if the petal length less than 2.5, we know the flower type, that is setosa, isn't it? Yes. Do you need machine learning for that? No, you don't, right? You don't. You don't need that. We can really say by, especially in exploratory analysis, by looking at it, we know how to separate out setosa compared to others. Other two is difficult. No, he is not able to do that. But I think the setosa is the easiest thing. Yes, agree? Okay. Because we are going to witness today using decision tree algorithm, it will separate these three classes. And now, since we know this information, this is useful for us for our future. Right. Okay. Any questions up to this point? Just to summarize what we did, we got a data set, we observed the dimensions, we got 2 columns, we visualize it, and we have made some observations. Yes? Okay. Have we done any machine learning yet? No, we don't. We have not done any machine learning yet. Right. Now I have to talk about some machine learning stuff, which I have not discussed the theory. Now we are going to use some algorithm to build some what we call the data model or machine learning model to separate this data, right? We need to separate the data into 3 classes. When we have a new flower, we want to predict. Now remember, we have a limited data points. How many data points we have? How many data points? 150. So when we are developing a model, we should not use all our data points. Why? Now right now we don't know which machine learning works well. We need to have some measurements to see which one works best. So the first thing that we are going to discuss today, we are going to divide our data set into 2 parts. One we call training, other one we call testing, or train and test, right? This splitting we can discuss, and I'm going to have a separate session on there are different ways you can divide as well, right? But the most common one is usually, right? 2/3 of data we take for training and 1/3 we use for testing. Fair enough. But you will see when you're reading papers, some say 80 to 20. There are other various methods you can split. Right? Commonly, I'm going to say that if you're a beginner and if you're new to machine learning, okay, if you have no clue about the data set, yes, let's go with this. Okay, this is the code for dividing the data set as training and testing. So for this one, I'm going to use some methods already available in scikit-learn, and I'll put the code there as well. So for separate out the data set, I'm going to use this piece of code. I will copy it into your chat session. I'm going to use chat. I will type it there so you can copy paste, right? So then I will explain what it means. So what I'm going to do, I'm going to separate the data set as training and testing. So the method is called train test split. It will take 3 arguments. X is the data set, Y is the labels, and this is the test set size. 1/3 means 0.33. Agree? Yes? Okay. Now, when you use that, it will generate 4 data sets. X-frame, X-step, Y-frame, Y. Okay. Just copy paste from the chat. I put the code in the chat. You don't have to type. You can take some time. Just copy paste it. Just to type. Type. Now check the sizes. You know how to check the sizes. So this code, what it does, divide the data sets two-thirds for training and 1/3 for testing. If you need 50-50, what value we need to change? Let's say I want to change 50-50. Set size we put 0.5. Hope you now understand. Remember the code assumes that the capital X for the data type, simple Y for the labels. Look at the dimensions. Now check these 4 dimensions. You know how to check the dimensions. Data sets are the main. How to check? What is the code? Yes. Shape, right? Use shape. Just check the shape. Let me check the shape. Okay, here is my one. It will divide. Let me take X-train dot shape. Now the train is 100, right? So that means that's okay, right? X-test dot shape. So now we can see 100 data points for training, 50 data points for testing. Okay. So I told you like the why we need this. We need to separate the data points like this because what we are trying to do next is we are going to build a model using this one, and then we can test using the remaining data points, right? Okay. Now let's build the model, right? When you're building a machine learning model, we can use many classification algorithm. We have not discussed the theory. Remember, theory we have not discussed the theory part, but I will have a separate session on that. But let's build a decision tree, and I will share the code with you. So the code is for the decision tree look like this. I will put in the chat. Code for the decision tree model. Right? So we select the decision tree model. We have not done anything. What we do here, we select the decision tree model. So we are going to get the tree. We are going to import from scikit-learn library. And we are going to under the tree, there are many tree algorithms, we will select decision tree classifier, right? That's all we did here. Yes. Any errors? No, right? Nothing. Yeah, what we did now, we invert the Excel, we have selected the step we have not done anything. Now let's train the model. Let's fit the model, or we can say train the model. So training is known as fitting it, right? And when you're fitting, so what we are going to do is train the model. So here is the code for train the model. So we have to get classifier dot fit method. So fitting means we are going to train. Now we have to specify what X and Y are. So we are going to use X train, comma Y train. Because we are using only the training data to fit the model. And let me say that this is the CLF. I'm actually going to use a variable CLF to hold the model. And run. So this will create the model. Now the CLF classifier, we have the model, right? Some of the model you can't see, but originally this one you can visualize and see. Some models black box, some models white box. You can we don't know what is inside. But originally dictionary you can see what is inside. Again, I will give you a code for that. So this classifier, this variable holds the model, and this is the model we are going to use when we need a prediction. Okay, now let's visualize this. Visualization code is a bit lengthy one. I'm not going to explain that, but I will give you code for this, right? So let me give you the code for this. Again, I will copy paste, put it in the chat. Just put this and run and observe the answer. So observe the outcome. So I'm going to get the code. I'll copy paste. It's a visualization code. I can explain if you want me to do. Simply, there's a special dot format we can extract from the model, and it will display. And this will create what we call an image file, and it should be something look like this. So were you able to get the tree decision tree algorithm? Yes. How come? Get it from the original. Okay. Only thing you might have is now can we try to increase this? Now, can you see this data set? Now the root node now. So this is this is what the model says. So the top root node, it says petal width. If the petal width is less than or equal to 0.8, then it says if it is true, then the data point as classified as class setosa. You see the point here. So can you see that only place you will setosa is in this place? You see this color because the colors are separated, right? Setosa in my case in brown color, versicolor in green color, and virgilica I think purple in my case. So you see, setosa is the easiest one, isn't it? As you observe, even in the decision tree, tells us you can easily separate setosa. Yeah. So okay, there's a question why you are getting different trees. There's a reason because when you divide the data set, it's random and we might getting end up with different trees. So don't expect my tree in your trees. Randomness is always there. If you want to fix that, you have to specify seed value. I told you this. If you want, for example, experiment should be repeatable, then you have to specify a seed value. If everyone are using the same seed value, we might end up getting the seed. But someday again, but I think can one of you share your screen with us because I won't show that one as well. So let me allow the others to share their code. Vishaka, can you share your screen? Because we want to see that. Because I made that same. For example, Vishaka's ones, you can notice that. I'm sharing the one. Just sharing. Now, can you read the model? Can you identify? Are you comfortable with prediction? Like, let's say, if I give you like 4 measurements, can you go through the tree and tell me the outcome? Is it possible? You should be, right? So let me share my screen again. You see, sir, now I have repeated my one, now I am getting that. You see what has happened because randomness is there. It will give you different. I think you better understand these ideas. Now, this is a clear observation that we have made even before we apply machine learning. If the petal length is less than 2.5, we knew that it's specified as setosa, right? So that we have already have seen. Right. Okay. So let's go through this now. The leaves, what is in the bottom, they are known as leaves. They are the final classification. Leaves or the final classification is the right. Setosa I love up there. I mean, some classes you have to go down in the tree, right? You have to do multiple tests. Simply for some, you have to perform multiple tests. So the theory part we have to cover separately, but now we have implemented it. We understood what a machine learning model is. One leave. Let's select this one. Last one. It came through this, right? Start from here. First one, the petal length should be less than or equal to 2.6. It should be false. That means a petal length should be greater than 2.6. Then when you measure the petal length, whether it's less than or equal to 1.25, it should say yes, right? Then petal length should be less than or equal to 4.95. It has to say yes. Petal length, petal width should be less than 1.65. If that is the case, the final classification is versicolor. That's how it goes. So from the top root node to the leaf, you have to perform all these tests to get the final classification. We have a theory class next week. So next week we are going to have a theory class on how we are going to build the decision tree since now you are now really curious about like how this works. Couple of things I would like to discuss from the beginning. So for example, you can see here, since the Gini information is the highest value in this particular decision tree, Gini has the highest value and that's why it's in the root node. And you see when you go down, the value will be 0. In the leaves check, Gini value will be 0, right? At the same time, you can see the number of samples. We started with 100 samples because the data set we have divided 150 into 2/3, it's 100. And 35 goes here, the remaining 65 in the other side, right? Likewise, you can observe how many samples you have received, right? Okay. Now that we have discussed this, let me talk about prediction as well, right? Let's look at the predictions. Now we have a model, we have a test data set, isn't it? We have a model, we have a test data set. Let's predict this, right? So now we have a classifier, right? So the command is classifier.predict. So now we'll take the code, right? We have classifier.predict. What we are going to predict is using the test data set X test, right? And then let's put up this into a variable called predictions. Or you can just simply print it out. So let's say this is predictions, right? And let's print the predictions. Here are the predicted class labels for the last 50 data points. Last 50 data points. Right. Now check with what is already known. You already know the Y test. Check the outcome with Y test. Print Y test. One row you have the predictions, the other row you have true labels. How accurate your model is? Can you check and see? One is being predicted from our model. One is actual values. How accurate your model? 100%? 90%? 100%? No? Mine is not 100% because there's error here. So in my case, I have 2. Here, the prediction is 2, actual is 1. So you can calculate the number of points. But let me give you the code to find the accuracy. I will put in the chat. Here is the code for find accuracy. I put in the chat. Use this one. So let me take mine. Let me see my accuracy. My classify accuracy is 96% according to this. What about yours? Huh? 96. Yours? 98. 98. Yes, 98. 98. So mine is 96. Yours 98. You know why? So there's a variation of this. So what should we doing? I mean, how do you reduce the variance? How do you reduce? We can iterate multiple times, isn't it? To get a reliable estimate of our model accuracy. So maybe that's why we sometimes use 10% gauging. I don't know these things later, right? Right for the right? Yes. And only problem is that no guarantee here. If you don't have how do you make sure that your model gives you the next time? Right. Okay. So I think yes, we did the length testing. Now we actually came almost to the end of today's session. So we got a data set, we visualized it, we built a distributed sequence of the smart, right? And we predict the labels, we got the accuracy there, right? Now, right now, we really don't know whether this is the best. But if this is the best one, we need to use whole data set to build the final model. So we have to use all the data points to build our final model. So can we build the final model now? Now we are going to do that. So this is the final model. Now we have left out some data to validate our model. Let's say I'm fine with this model. Now for the final model, let's combine the data, right? So let's build the final model. So building the final model, we have to repeat this again. So now we have to do what? Final model. We have to do again the same thing. Let's build our final model. Now this time I'm using the X and Y, not X train, Y train, X and Y. And this is my final model. So let me run this. And then let's visualize. You can use the same code to plot. The previous same code to this, visualize. And remember, final one should be same for all of us, isn't it? Final model should be the same, I guess, isn't it? Final model, because we are using same data sets, right? You can use the same code to get the visualization. So, yes, shall we summarize what we did for today? So let me summarize our work for today's class and today's session. So I told you about the data set. We did machine learning decision tree algorithm with Iris dataset. We got the dataset from scikit-learn. And then we observe the dataset. We visualize the dataset. Right? We visualize the dataset. Right? We made some observations. And then we divide the datasets as training and testing, because I told you in machine learning, we need to separate the dataset. And we build the decision tree classification algorithm. And we made some predictions. We calculate the accuracy, and finally, we build our final model, right? And now with this one, we can use to predict when we get a new flower. You can read the measurements, and then by going through this, we can get the predictions. So I think in the next session, we can talk about a little bit of theory now, since you already know the coding part. We can talk about, for example, machine learning process, the workflow, plus some basics of these algorithms. So we can spend a couple of sessions on understanding the basics, and then again, we can get back to code. I hope you enjoyed the session, and we'll have the next session next week, hopefully, on basics of machine learning. Thanks, everyone. We'll meet next week there.